Okay, hi there, Robin Andrews here from Academy, and I'm finally continuing my snake video using Python and Turtle graphics to implement the snake game. Now, there's been a few reasons for the delay. One of them is I've actually come up with an implementation that I prefer. Having said that, I really want you to finish this one because there's so much to learn from all the little details of this implementation, and then you'll have something to contrast it to if you look at the other implementation. Also, it's just good to kind of see multiple ways of skinning a cat. I don't like skinning cats, but you know, in programming, there's this whole thing about multiple approaches is really important because it's not just being able to fix something sometimes or solve a problem, but it's understanding all the different ways that you might solve it and then choosing the most appropriate given the context. Okay, so it's quite a in-depth skill that you're developing here. So seeing multiple ways of doing something is by no means a bad idea. That's my disclaimer for the choice to change my implementation. So let's have a look. Let's say we've got a snake and we have a tail with some segments, okay? And let's say we've got 3 segments. So we're actually just here going to look at purely conceptually how the snake is going to move. Now, the way I've done it in this implementation for the video is a little bit strange, but I'm going to talk you through it. What we're going to do is we're going to start at the end. So let's, I've got this pixel clicker here. And by the way, if you're interested in this, this is from Code Club, and it's one of their resources, one of the HTML and web technologies projects. It's really good. So much you can learn just from this, but I'm just using it as a teaching tool. Like I say, if you want to check it out, maybe I'll put the link in the description if I remember. It's Code Club, that's the Raspberry Pi crowd. But anyway, that's not the point. The point here is I'm using it to teach. So let's say we're going to move this end one first. Okay, so first of all, I'm going to give them colors to make it clearer what's going on. Obviously, I've got limited colors here. I could modify the code to get more, but this is enough for this particular snake. So the head is black, and then we've got 3 tail segments, okay? So what we're going to do is we're going to start at the end of the snake, and we're going to move that one up to the position of the one before it in the body of the snake, okay? So that green one is going to become blue now, okay? And this one will actually have disappeared. Then the next one, which was green, is now going to be this one. And then the one which was red is now going to be this one. And then the head finally gets moved. That's the order. If we don't do it in that order, the way that I've coded this is going to mess things up, okay? So let's just do that again, if I can remember the exact sequence. Clear these all up. I had a head and I had a body consisting. Let's do a different angle actually, just so you can see what's going on again in a different way. So let's say there's no curve in it this time, but it's the same number of segments. Now, I think, can't remember the order that I did now. Pretty sure it was that order, right? So we want to move the last one first. So this green one, okay, now goes here and no longer exists where it was. This one that was red now becomes the blue one. The head now becomes the red one. And then finally the head can move in whatever direction it's going, okay? Now, tracing this kind of algorithm or tracing algorithms in this way actually is a really important skill. So just on a very conceptual level, sometimes using paper or a trace table or a really useful tool like this, obviously it can be improved for this task. There'll be ways of making it more appropriate for this particular task, but I'm using it for other stuff as well. So it's fine as it is generally. Really important part of your algorithmic thinking and your problem solving in general. Okay, so don't be afraid to spend quite a lot of time trying to understand what's going on just on a conceptual level, away from any code. And then when you come to write the code or read the code and try and understand what it does, it's going to be a lot easier for you to understand all the subtleties of what's going on, okay? So that's how the snake moves in terms of just the visuals of it. And now we're going to move over and look at the code. Okay, so this is where we left off last time. As it's been a while, I'll just give you a quick recap of what we did. We had some modules that we need. We had some constants that we're going to use in the game. We had a way of moving the snake based on its current direction. We would modify its direction if that didn't involve a self-collision by going in the opposite direction to its current direction. That's what that does. Then we had some callbacks for the keyboard key presses. Okay, then they were the functions, so they're at the top of the file. And then we had the main code. So we set up the screen. We did some binding of the key events. We set up the snake head, we set up the food, and then we had this while loop, which we're going to get rid of first thing because it's not good practice. Okay, it was a quick and easy way of getting you to see how animation could work in Turtle graphics, but there's some problems with it. So let me just turn on line numbers while I think of it. Yeah, we don't want while true loops because there's also a loop going on in the background. When you do turtle.done, you're creating a tkinter or tk into main loop anyway running in the background. If that doesn't make sense, don't worry about it. Okay, so we got this function called play starting on line 38 here. And within this function, we call the move snake function. And we call the check food collision function. Then we update the screen. And then we call ourselves after a certain delay. Now, this is quite an interesting concept. It looks a bit like something called recursion, if you've come across recursion. The way it's implemented, I don't believe actually creates recursion. I think there's some way of avoiding stacking up the function calls, just in the way this is implemented. Again, probably too much info for some of you, but the main point is we are on line 42 here. I don't like the way it goes grey when I click on it, but it'll have to do. So on line 42, we're calling turtle.ontimer. Okay, so that means after a certain delay, which we've defined at the top as our constant, we're going to call a function, and that function is going to be the function whose name is play, which is the very function which we are currently inside of. Okay, so you can see what's happening. We're inside a function. Within that function, we make a call to ourselves. Okay, so you're going to get this loop. We're creating a loop. Okay, it's a little bit like using while true, okay, because you've got this kind of looping action going on, but it avoids some problems. And this is like the way you're supposed to do it, right? So within our loop, we're calling move snake, and I've moved some of our code into individual functions that we'll look at in a moment. Okay, so we move our snake, and we check for our food collision, we update our screen, and then we call ourselves after a certain delay, which will just repeat this sequence of function calls. Okay, so that's how we're controlling the animation. So we used to do our food collision in our while true loop, okay? That's going to be taken out into its own function. So we said if the distance from the food and the head was bigger than a certain size, then we have a collision, we move the food, etc. Right? So we're going to put that collision code into its own function. That's the first thing we're going to do. So we'll add that up here, maybe after move snake. We're going to do def check food collision. Okay, there's no arguments, and that's going to be exactly this code that was previously in the while loop. So I'm going to get rid of that. Actually, I can just cut it and paste it, and paste that into my check food collision function. And it's got the wrong indentation, so I will do. In most IDEs, let you do Shift Tab, but I'm pretty sure that's not the case here. No, it's not. So if I want to take those back, I'm just going to do it manually for now. It's very useful to have Shift Tab, but idle doesn't let you do it. Okay, so they're now at the right indentation. Just save as we go along. So that's all good. Let's just see where we're at now. If we get rid of this loop, so we don't want the while true loop anymore, but we do need to start the whole thing off. If you think about how this is working, let's just add a comment here. Let's go. Right. The way this is working is we've got this recursive function, or this function that calls itself, called play, but we haven't called it once, so we haven't kind of started the whole domino stack. Yeah. So let's kick it off by calling play. Okay. Now, no idea where we're at because I've kind of jumped in the middle. So let's see if this is going to run as it is. So press F5, and we'll see. Expected, yeah, that's fair enough. Why wouldn't you? So all of those, because they're inside an if block, can be indented. Okay, and I've just seen a little bug that's going to cause problems. I've called play before I've given a direction, okay, which means that property doesn't exist. And Python's going to complain. And just one more thing we need to change before this is actually going to work. Up here we've got delay. It was, I think, 0.5, which was when we were doing using time.sleep for a certain number of seconds. But what we're dealing with here now is millisecond delays. So that needs to be an integer. and it's no longer seconds, it's milliseconds. Let's have something like 200 maybe. We can change that later for different speeds, and that's milliseconds. Okay, so now when I run it, hopefully, okay, so we have the snake, we can control it with the keyboard, we can collide, okay. So that's all basically the same as it was, except that we got better code, better practices going on. Now, for example, if I close this, you won't get a horrible error, whereas before you did, and the reason you got a horrible error is you had a while true loop, so we never got to this turtle.done, which is what enables us to exit smoothly from Turtle graphics programs. Okay, so that's what that was about. Okay, so next what we're going to do is add segments as we catch food. Okay, so if we catch food, then we add a new segment. So inside our check food collision, we're going to make a comment. First of all, add new segment, and we're going to do new segment is equal to a new turtle. So the big overview of what we're doing here is everything in this particular implementation is an individual turtle. Yeah, so each cell is a turtle, each piece of food is a turtle, the head is a turtle. There are different ways of doing this. Particularly in my other implementation, we're using a stamp. So we basically just got two turtles, one for the food and then one for drawing. So you can call it pen or whatever, stamper or whatever. And it stamps as it goes, which is a completely different approach. Both of them have their virtues, but I'm just pointing out the difference here. So in this context, we've got a new turtle for every item on the screen, basically. So new segment equals turtle dots. Okay, so we're creating a whole new turtle for each segment. And then we can do some stuff like new segment dot shape. We want to use squares. Okay, that's the inbuilt shape from Python Turtle. We want to do the color with the American spelling, and let's have cyan. Okay, nice sky blue. And we want to not have it drawing, so we're going to do pen up. So new segment dot pen up. And finally, we need to append this to a list of segments. Now, we haven't actually created that list yet. I'll do that in a moment, but we're going to do segment, is that right spelling? Yeah, segments.append, the new segment. Okay, so that's not going to make sense unless we have that list of segments. So let's put that here. Okay, so this is basically containing the body, and we start off with nothing in there. And then when we get a bit of food, we append to that list. Okay. And all of that should actually happen only if we get a new bit of food. Otherwise, the snake's going to grow very quickly. So indentation makes a huge difference in terms of the logic of Python programs. Okay, so we've appended a new segment. I also just want to change a color because a different flavor this video. We're going to have a nice pink and cyan. It's quite a nice color world. So that's not going to do much noticeable. In the background, this segment list is going to be growing when you catch food, but it's not going to be rendered to the screen, so it's not going to be noticeable to the player. So we're going to now deal with segment movement. And this is where the earlier part of the video becomes very relevant, again, the logic of it. So what we're going to do is, inside of move snake, the first thing we're going to do before dealing with a head, remember I said we deal with a tail, and then we deal with a head. So inside of move snake, we're going to do for, we use I, but index is more explicit, in range. Now this is, you may not have seen this, this is backwards counting because we need to start at the end of the snake and move to the front, otherwise it just doesn't work in terms of the movement. So we're going to go the len of segments, and I've got some articles about this on my blog somewhere. If you get confused with this, I'll put a link in the description. But the len of segments minus 1 is our starting point, right? And then we're going to go to 0. So let's say there was 10 segments. Okay, this would start at 9, right? And it would go to actually just to 1, because the same as when you have upper bounds that don't go right to the upper bound, it's the same when you're going backwards. If we put 0 as our lower bound, it would actually only go to 1. I'll clarify that in a minute. So then we've got -1. So we're counting in steps of -1. So basically that means if you've got 3 segments, then it's going to go from 2 and 1 and not hit 0. So 3 segments, this loop will just hit segments 2 and 1. Okay, and you'll see why as we carry on. Like I say, there's a whole thing in itself, this backwards iteration. So if that confuses you, check out my blog or other resources on counting backwards in a for loop in Python. But that's basically how you do it. Okay, so we're now going to create an X value for our new segment, or for the current segment, I should say. And that's going to be index -1 dot xcore. Now dot xcore gives us the current x coordinate. Y, might as well just copy that line actually. A lot of IDEs have a duplicate keyboard shortcut, but I don't know about idle. So you can just duplicate a line and then modify it. So Y is going to be the Y core of this position. And then segments index, sorry, segments at the index go to, that's going to be the X and the Y. Now what on earth is going on here? Let's try and break it down. So we're moving the snake. We want to move the tail first and then the one further forward towards the head from the tail. Yeah, so we're iterating backwards through our segments list. We're looping backwards through our segments list. We're taking the one at the end and moving it to the position of the previous one. Okay, that's what this index -1 is. But we're only doing this up to the one before the head, because the one before the head needs handling specially. Okay, you're probably confused at this point. I'd be surprised if you weren't, but if you're not, then great. So you need to go back to the visualization at the beginning, maybe get a pen and paper, try and understand this movement at a conceptual level. Okay, and like I say, there are easier ways or more elegant ways of implementing it, but you're going to learn a lot by doing it this way anyway. So that's that one. So that works for all of the segments apart from the last one. The last one moves to the next to last one. The next to last one moves to the one before it. But the one just before the head has to move to the position of where the head was. And the head has its own specific coordinates, okay? It's not a member of the segments list. So that's why the one just before the head has to be treated separately, because it's referencing the coordinates of the head rather than a previous item in the segments list. Okay, hopefully you're not too confused. Like I say, this stuff, you have to spend time, you know, if you're lucky, you get that aha moment straight away and it's like, I get it. If not, you have to go back to the drawing board and try and understand what's going on. Paper is a great way of understanding algorithms. Okay? Don't be afraid to use paper to, to really grasp what's going on. Okay, so that said, let's go back to where we were. So we're going to deal with that section just before the head. So make a little comment maybe. Move segment 0 to where the head was, or where the head is, because we haven't moved the head yet. So if len of segments is greater than 0, so that means if there is any body at all to the snake rather than just being a head, that means there is going to be a cell just before the head and we have to deal with that. So if the length of segments, that should be outside, is greater than 0, then x equals head dot xcore. Okay, and then we can copy that and paste it. Probably just too quick to type, but hey. So y core, that's going to be the y core. So this is exactly, so line 20 and 21 here is exactly doing what 14 and 15 were doing, except we're doing it for the one just before the head, which needs to be treated separately for reasons I just explained. So now we need to move this to the new position. Segments 0 dot go to x comma y. Okay. Lots of blank lines here. Some IDEs have an auto format, which I love, like PyCharm. You just hit auto format and everything gets like, all the little layout bugs get sorted for you, like the right number of white lines and things. But don't think idle has that. So we'll just have to make do with the odd discrepancy in spacing and things. Okay, so I think that might be everything. So the first part of this move snake function moved all of the tail up to, but not including the one just before the head. This part here from line 18 to 22 moved the particular cell just before where the head is, i.e. segments 0. And then what we had before just dealt with the head anyway, so we've already got that going. Okay, so a couple of little bugs just before we run this. Len segments 0, that's left over from when I took the greater than out of there. And I've also just noticed here we've got segment rather than segments, okay, which is a nasty little error that will break everything. Okay, so I think that should do the trick now. Let's run it and see. Okay, so our snake is growing. This is good. It's still growing. Okay, now you might notice that each cell appears in the middle. Just briefly, we can deal with that, but I want to wrap it up now because it's been quite a long video already. If you want to look at that, there's a method called hide turtle. So you can hide the turtle and then redisplay it at the appropriate time. But I'm actually quite happy with that. That's pretty good. So we've made quite a lot of big changes. I just quickly revised them. We changed delay to milliseconds rather than seconds because we're no longer using the time module. Get rid of it completely, actually. What else? Move snake is now dealing with the body of the snake as well as the head, and it's doing it in the order of the tail, the one just before the head, and then the head itself. What else? Check food collision. Now, yeah, if you collide with some food, you now add a new segment to your list, which is how the game works. All of this is the same, but this is different. Okay, so when I say all of this, I mean the handlers are the same. But then the way we're looping is very different. We're using the ontimer functionality, which will call a function after a given delay, and the function it's calling is itself. So we're creating a loop here, but we're doing it the proper Python turtle way. And in that loop, we're moving the snake, we're checking for a collision, and then once all that's done, we're updating our screen manually. Because remember, we disabled automatic updating earlier on when we did screen.tracer0, so that's why we need to update. And then once we've updated the screen, we call ourselves, and that's all good. So anything different? Yeah, just the way we kick off now is we create an empty list of segments, we set our direction, and when everything's ready, we make that first, we push over that first domino, right? We push over the domino, which gets this function looping and calling itself infinitely after a given delay. But doing it that way enables us to actually reach line 105 in our program, which is the one that lets us close the window without getting an error message. Okay, so let's just run it again one more time so you can see it. Okay, to say yes, they were just like little formatting changes. There it is, snake game. Right, so thanks for watching. We'll probably in the next video look at scoring and maybe some kind of like reset, like how we're going to, you know, if the snake dies, how we're going to handle that. But that's it for now. There's quite a lot to take on. So, you know, if you do spend the time on this and really understand what's happening, you will certainly advance your understanding of programming and Python and turtle graphics. So I recommend that you persist. And again, I apologize for the delay in bringing this one out. I'll bring out the next one after a shorter delay. Okay, thanks for watching. Don't forget to subscribe, and I'll see you in the next video.